Hello and welcome to my first episode of digital circuiting. And first thing that you need to learn before we get into the actual circuiting, which by the way we'll be using Minecraft to simulate all of our circuits. It's pretty accurate, and there's nothing really that you can't do with it. But anyway, the first thing that you're going to need to learn is binary, which is the counting that computers do and the numbers that computers do. And you're going to need to understand that to go on to understanding later. So our number system now is in base 10. So that means we count 1 to 9 and then we go to the next one. In binary you go 0, 1 and then you go to the next one. 0, 1 and then you go to the next one. Or kind of. It kind of works like that. As you see, I have these counted in binary from 1 to 15 for our first 4 bits. Which each bit is each number. So the first bit, it is right to left, first bit, second bit, third bit, fourth bit. As you can see here, I have it lined up. So pretty much what a 1 means is that it's counting that bit, and a 0 means that it's not counting that bit. So let's take the number 1 for example. It's not counting this bit, it's not counting this bit because there's a 0, it's not counting this bit, and it is counting the first bit. So what we do is well, there's no 8s, there's no 4s, there's no 2s, there is a 1. So this number must equal 1. Let's move on to number 2. We got 0, 0, 1, 0. So if we go to the first bit, we're not counting a 1, we are counting a 2, we're not counting a 4, and we're not counting an 8. So 2 plus 0 plus 0 plus 0 equals 2. And then let's skip down the line to 7. 0, 1, 1, 1. So the first bit we are counting, so that's a 1. The second bit we are also counting, so that's 2 plus 1, so that's 3. And the third bit we are also counting, and we're not counting the fourth bit. So that's 4 plus 2 plus 1, which comes out to 7. Now if we move even further down the line to 13, we'll do 1, 1, 0, 1. So we are counting, we are counting the first bit, we're not counting the second, and then we're counting the third and fourth. So that would be the number 1 plus 4 plus 8, which comes to be 13. As we move on the line, we'll move down all the way to 15, which is 1, 1, 1. So now pretty much what we're doing is they're all 1s. So we're counting the 1, the 2, the 4, and the 8, which all adds up to 15, because 2 plus 1 is 3, and then 8 would be 11, and then 11 plus 4 equals 15. So another way that you can think about it is, so it's 0 or 1. A 0 means it's not counting it, so it would be a false, and a 1 means that it is counting it, which would be a true. So it's either a true or a false. And under each one of the bits, it's going to be a true or a false whether or not you're adding in that number. So if it's a 1, it's a true, so we're adding 1, and then the rest of them are false. And this does continue on as you can figure out these numbers under the bits. So let's say we want to go to the 5th bit. It's just whatever that number is doubled. So 16, 32, 64. So as you can see, doubled 1 is 2, doubled 2 is 4, doubled 4 is 8, and you can see as it goes on through that list. And that's pretty much it for binary. That's how computers talk. They since it can only be there is voltage there or there's not voltage there, at least with our current standard in which we use. And in another episode we'll talk about using different base systems, but right now we use binary, 1s and 0s, and that's how you convert those 1s and 0s into what numbers that we understand on a regular basis. When it comes down to building calculators, making counters, you're going to need to understand and be able to count in binary. And anyway, thanks for watching, and come back next time.